Now, in the previous sessions, we were dealing with something like log to the base of 10 of a large number like 100,000. And we said this gives us the value of 5. And I think it might be quite useful to do a sort of a little bit of an excursion into how these numbers actually work and what values this log 10 can actually assume. Because that is something actually that a lot of students find quite challenging. So we said log 10 of 100,000, that's 5, because we can write 100,000 as 10 times 10 times 10 times 10 times 10. So we've got it 5 times. 1, 2, 3, 4, 5. And likewise, we can write log 10 of 10,000. We can write this as, well, how many zeros do we have? We have basically 1, 2, 3, 4 zeros here. And that's another way, because we can write this as 10 times 10 times 10 times 10. And that would be number 4. Log 10 of 1,000. And again, that gives us 3. Log 10 of 100, that gives us 2. Log 10 of 10. We had that before, and we found that this gives us 1. Okay, so far so good. And this actually helps us to then make an estimate what numbers actually should be. And I'll show you in a minute what I mean. So now let's go down another 10 step, if you like. So we've got from 100,000 to 10,000. That was a step of 10. Here we've got a step of 10. Here we've got a step of 10. Here we've got a step of 10. So log 10 of 1. What do you think this will give us? If you look at that, well, actually it gives us, yeah, if you said 0, then you're right, it gives us 0. Absolutely right. And now let's see if we can actually figure out what happens if we've got log 10, if we do another step of 10, of 0.1. Now this is again is a step of 10 here. And what do you think if you look at these numbers here? So we go from, let's say, 4 to 3 to 2 to 1 to 0. So your intuition would tell you that log 10 of 0.1 gives us -1. And you would be absolutely right. What about log 10 of 0.01? And again, if your intuition tells you that this would be yet another step of 10, then again you would be right, it would be -2. But don't take my word for it, let's head over to our calculator and see if we are right. So here's the calculator, and we want to calculate log of 0.01. Let's see if we get -2 for it. Yes, we do. So our sort of prediction of this this series is absolutely right. And this actually shows us what we can do. Now we can say, we can go even further. Log 10 of 0.000001. Let's see if we can say what this might be. That would be 1, 2, 3, 4, 5, 6 zeros. That would be -6 in this case. So the value, what we learn from that is that the value of this log can be either a positive number, or So whatever is in the bracket, so log 10 of, say, a, can be positive. I write this like that. It's a positive number as long as what is in the bracket is larger than 1. So a larger than 1. Or it will be a negative number if a is smaller than 1. And it will be 0 if this, what's in the bracket, this is the placeholder, if a is exactly 1. Now, can we do negative numbers? That would be the next question. So can we do a negative number in here? Let's say log 10 of negative 10. Can we do that? Can this number in the bracket here, that's the question, can it be negative? Can it be negative, this number? What do you think? Well, if we don't know the answer, let's see what our calculator says. Okay, so calculator. So we want log of a negative number, let's say log negative 10. What does that give us? And let's see, equals, oh, it gives us something really, really weird. This gives us a number and it looks really strange. And this is because this is a scientific calculator. Actually, it does do calculations, but it gives a strange number. And for non-engineers, the answer to that, whether we can do a negative number, would be no. Can it be negative? No. It cannot be negative. This number in the bracket cannot be negative unless you're dealing really with higher maths. But we are not doing that here. So we cannot actually reasonably do the logarithm of a negative number. Our numbers in the bracket always have to be positive numbers, and they have to be, well, can it be 0? Can we do log 10 of 0? Let's see, can we do log 10 of 0? What does that give us? Let's see. Let's try it out. Log 0. Oh, it gives us, it says here runtime error, it gives us infinity. Now that's interesting. So this gives us infinity, and I indicate this with this sort of keeled over 8, which stands for infinity. Infinity. So it means we can't do any calculations. So the number in the bracket, number in the bracket of the log of log, so this would be log 10a, that's the number in here, that's this number, must be larger than 0. So that's really important. And what a lot of people really get confused about is that the number in the bracket of which we take the logarithm, it must be larger than 0. But the value of log 10 of a can be negative. As we said above here, so as we've seen here, the number can be negative if what's in the bracket is smaller than 1, or it is positive. Let me highlight that. So it is negative if what's in the bracket is smaller than 1. It would be 0 if a equals 1, and it is positive if a is larger than 1. So don't be thrown to the floor if you get a negative value for log of a number. This just indicates that a is smaller. So a is smaller than 1. And it is negative if a indeed is smaller than 1. So this should help us a little bit to understand what's going on with these logarithms, and also to make sure that we are not totally perplexed when we see something that gives us a negative value for our logarithm. That's absolutely fine. What's not okay is if we've got a negative number inside this bracket. So this is something that we just simply cannot deal with, and we are not going to deal with here during this course. So I hope this makes sense. Thank you very much for watching.